if you turn this video at one point off, please tell me what the reason for it was, so that I can improve. Otherwise, hi and welcome. I'm trying to learn particle physics today, how the Higgs was found, and after we've done that, we're going to do standing yoga. And if you participate in the standing yoga, then this will at your own risk. What happens if you break matter up into smaller and smaller pieces? Eventually, you get the component molecules or atoms. Okay, we're having matter, we're breaking it up, and now we're having the component, the molecules and the atoms. But these can be further broken down into electrons and atomic nuclei. So if you have something, a book, and you break it down into the smaller matters, we then find out these are actually atoms. And these atoms consist, when we can break them further up, on the outside are the electrons, and in the middle, the atomic nuclei. The nuclei can then be torn apart to reveal their constituents, protons and neutrons. So the atoms, having at the outside the electrons, and inside of the atomic nuclei, there are protons and neutrons. Inside these, there are quarks. So inside of the protons, now inside of the nuclei, of the atoms, inside of this book, there are protons. And inside of these protons, there are quarks. At this point, you have reached the level we regard as fundamental within the Standard Model. So the Standard Model in particle physics is about these things inside of the protons, these quarks. And a bunch of particles like electrons. Whatever material you start with, at some point you end up with a bunch of quarks and a bunch of particles like electrons. So whatever element, whether it is a book, whether it is some plastic, some glass, some metal, or whatever, at the end you have atoms consisting out of electrons, and in the middle these protons and neutrons, and inside of these protons these quarks. That's it. Matter gets no smaller than this. This neat particle pattern fits the experimental facts, but hides a perplexing problem. Okay, we're saying that is very easy to tell. You have matter, a book, that consists out of millions or billions of atoms. Every one of these atoms has at the outside the electrons, in the middle is the atomic nuclei, where the protons and neutrons in, and inside of all these protons there are quarks. And it doesn't get smaller, we have it, it is so easy. But now, it hides a perplexing problem. All matter particles have a property called mass, a resistance to being moved around. This mass varies by over 11 orders of magnitude from the lonely electron neutrino to the relatively homunculus? I don't really know the top quark. Okay, they're saying these little particles inside of the protons and neutrons, and maybe even inside of the electrons, whatever, they are have not the same mass. Some of them are heavier as other ones. And that doesn't really make sense, I think is what I want to say. Where do these masses come from? And why are they so different? Now, let's look if we get an answer. Within the Standard Model, the fermions that make up matter interact through forces transmitted by particles known as bosons. So the Standard Model, that is basically there are these 30 particles or whatever, and they say inside of the protons there are these quarks, there are up quarks, down quarks, and they come together, and two up quarks or whatever, one up quark and a positive or whatever, they're making together within a proton or so. At the end this is positive. And the electrons, there are two negative quarks inside, and then it's an electron or whatever. I don't really get it. The idea is like that. And there are 30 particles, and we're saying these 30 particles, that is what all these atoms consist out of, what is everything existing out of. And they have a different weight, a different mass. And they are transmitting forces onto each other, these particles inside of these particles. So these quarks inside of the protons. And these transmitting of a force is happening through particles called bosons. So inside of these protons, there are not just three quarks. There are some bosons which are transmitting the force from one to the other one. So they having electromagnetic force onto the other one. I don't really get it. Onto another one, and there are no bosons, and they transport it from one place to the other one, like the photons. So the sun is shining, and then the light are photons. These photons, they are transporting the light. They are massless. Probably that's the reason why light is so fast. These photons, the quarks, they are differently heavy, or messy. In the case of the electromagnetic force, which holds the atoms together and drives the currents in our electronic devices, these are photons. Okay. Let these three quarks, I think it are three, inside of the proton. Don't just go their own way and the proton explodes and the whole universe explodes. They hold together by electromagnetism. They stick together very firm inside of the proton. I don't know if they're firm. They are in there. They don't get apart. That's the point. And that happens through electromagnetism. And this electromagnetism happens through bosons going from one to another one and holding them together. I don't really get it better. And that is also working in electronic devices somehow. And that are then photons. They said that photons are transmitting the electromagnetic force, but photons are also transmitting light. No, I don't know where the difference is. I get it. We did it in physics. Electromagnetism is the whole spectrum, from gamma rays, from radio signals, which are kilometers long, to gamma rays, which are very, very short, just a millionth of a millimeter. And in the middle of that whole spectrum, from radio signals, probably television also, I don't know, radio signals to gamma rays. In the middle is the light, the visible for the human eye light. When there were bats, I think I saw it a couple of times, there are bats or dolphins or whales, they can have other spectrums, and humans are here. So bats can also see when the light or something, and dolphins and whales, they can make sounds to other whales over long distances. They are somewhere here with the waves, and humans can see that form, that light. And it's all the electromagnetism. That was written very clearly, and that was very astonishing. That whole spectrum, whether it are radio waves, I think they're actually used for radios, so probably television waves, the waves, or the bats, or the humans with the visible light, or the gamma rays. It's all electromagnetism. And now it makes sense that it is photons who are making the electromagnetic force, because light is part of the electromagnetism. Photons are the light coming. These are actually photons. And photons are doing the electromagnetic force which holds the quarks inside the protons together. And it makes sense. Photons are part of electromagnetism because the whole spectrum is electromagnetism. The gamma radio waves, gamma rays, the thing that bats and the whales get, dogs are probably also somewhere there, and humans with the visible light. Photons, the same thing which is doing the light, is part of electromagnetism. It all is electromagnetism. The interaction of photons with matter depends on the magnitude of a fermion's electric charge. Electron has a charge of -1. Electrons are minus. Electrons feel the electromagnetic force more strongly than quarks do. They have a charge of -1/3 or +2/3. So you have I think you have 3 of them together in one proton. So you calculate them all together. You have one with a +2/3 charge, another one with +2/3, and one with -1/3. And at the end you come up with +1, all 3 together. +2/3, +2/3, -1/3, you have +1, a proton has +1. An electron has them probably the other way around. -2/3, -2/3, +1/3, and you have an electron. And probably that is the reason why you can split these things. I don't know, let's see. So an electron has -1s, and it feels now a quark more strongly than a quark, because they have a charge of +1/3 or -2/3. Charges, neutrinos don't feel it at all. So they're also neutrinos, not neutrons, neutrinos. And they don't feel the electromagnetism, because they have no charge. And now something with a stronger charge, which is bigger, is heavily hit. And electrons with a charge of a full -1 are heavily hit by bosons, by electromagnetism, so by photons, then just a little quark, a part of something which is just 2/3 of how. Quarks also have a separate color charge, onto which particles known as gluons latch to produce a strong nuclear force. They have a separate color charge, onto which particles known as gluons latch to produce a strong nuclear force. So it's something as a strong nuclear force. I don't really get them all together. What we're doing. But there's also the strong nuclear force, and that works with gluons. So the electromagnetism holding the atom together, and is the light, the photons, and it is transmitted by photons. And that spectrum by the photons is the radio waves, also photons. These are photons, the light, and maybe the rest also. That holds it together and is transmitted by photons. The strong nuclear force is transmitted by bosons, something else. This force is indeed much stronger than the electromagnetic force, but peculiarly gluons themselves carry color charge and so stick to each other. I don't really get what color charge was. What is? The gluons, they are sticking together a bit. Consequently, quarks and gluons are never seen roaming freely, but only ever bound inside particles such as protons and neutrons, and the strong force never breaks out beyond subatomic levels. The strong nuclear force, so the strong nuclear force is just that smaller way of work. There is also the weak nuclear force. Was it more? The strong nuclear force, what is it even doing? It is a much stronger force, and the gluons stick together. Quarks and gluons are always directly by the protons and neutrons inside of them. And they don't go over this subatomic level. So I think that is what I mean. Atomic level are electrons and the nuclei. Subatomic is now inside of the protons, inside the nuclei. They are always in there. These gluons and quarks. And that is why the nuclear force probably has only their force, the strong nuclear force. But the photons and electromagnetism is stronger. So maybe we are talking a bit away here. Not the same road. As for the third of the standard model's forces, the weak nuclear force, it is weak, but without it the radioactive decay that powers the sun and other stars would not occur. There's the third force, the weak nuclear force. So we have electromagnetism, the strong nuclear force, and the weak nuclear force. We don't have time yet. That means that was the particle physics part. In the next part, we're going to read that last part again and then try to understand it. That was not the particle physics part. If you were here for particle physics, you can go directly to the next part of particle physics. If you stay here and participate in the standing yoga, then it's very honest. We're having our feet standing together and we're breathing in and lifting the arms up, and we have just 3 minutes. And out and down. In and up. Out and down. In and up. And out to the side. In and up. Out to the side. In and up. Make an inch of space between the feet and open again to the side. In and up. Go to tiptoes. And out and sink down on tiptoes. Not too far, that can go into the knees. Then probably one up. Up again. And out, open to the other side. Down with heels. Up onto the heels, up. And out, sink down. In and up. Out the arms down, feet together, and the arm down. Breathe in, bend the right leg. And breathe out and stretch your left body. In and change. Out, stretch your right body. In into the middle. Out and down. Breathe in, lift the right hand up to the sky. Breathe out, bend the left knee and look over the right shoulder to the right hand. In and down. Out and down. Breathe in, lift the left hand up to the sky. Breathe out and bend the right leg and look over the left shoulder to the left hand. In and down. Out and down. Breathe in, come halfway up with a straight back. Out and down. In, halfway up, straight back. Out and down. Breathe in, lift the arms up. Come up again. Breathe in, lift the arms again up. Lean back and draw the shoulder blades together. In and up. Intertwine the fingers, breathe in, reach high. Breathe out, reach from all the back. In and up again. Out, cross the other arm, breathe in, reach high. Breathe out, reach from all the back. In and up. Out, lean the long arms back. In and up. Out and back. In and up. And out the arms down. Breathe in. The eagle's wings, and breathe in, out and down, in and up again, out and down, down and now bring the arms up. Bring the hands to touch, allow the hands down to heart center. That was the short standing yoga. I thank you very much and